This coming Friday, we're going to have a test. Unit 11, let me break it down into 2 days for the review. So let's review the first part. Find the value of the trigonometric function indicated. So I need to remember that cosecant is hypotenuse over opposite. Cotangent is adjacent over opposite. So I'm going to get my right triangle. I'm going to create theta on one side. I have the cotangent is 1. I need it as a fraction. So I'm just going to call it 1 over 1. So the adjacent is 1. The opposite is 1. Okay, so the opposite is 1. Remember, because cotangent is adjacent over opposite. So 1 over 1. I need to know how big is my hypotenuse in order for me to be able to answer the cosecant of theta. Now, for me to find out my hypotenuse, let me call it x for right now. I remember Pythagorean theorem, 1 squared plus 1 squared is equal to x squared. So I have that 1 plus 1 is equal to x squared. So I have that 2 is equal to x squared. That means that x is the square root of 2. Okay, so now for cosecant, I'm just going to say is hypotenuse over opposite. I'm just going to say radical 2 over 1, which is just radical 2. How am I going to type this? Radical 2. Now let's take a look at question number 16. I know secant. What I'm looking for, secant is hypotenuse over adjacent. I have sine of theta, and I know sine is opposite over hypotenuse. So let's see. I have a right triangle. Let me come out with my theta. It says the opposite is 4, and the hypotenuse is 5. I have no information about the adjacent at this time, so let me solve for the adjacent. At this moment, let me call it x. And I'm just going to say that x squared plus 4 squared is equal to 5 squared. I have that x squared plus 16 is equal to 25. Let me subtract 16 on each side. So I have that x squared is equal to 9. So it means that x must be the square root of 9, which is better known as 3. Now, sine, I said, is opposite of hypotenuse, which is what was given. Now, secant of theta is hypotenuse over adjacent. So I'm just going to write this as 5 over 3. The way I will type this will be 5 over 3. I gave you guys some ratios. I said the sine is opposite over hypotenuse. Cosecant is the reciprocal of it. As a matter of fact, let me give you guys the ratios in case you guys forgot them. I said sine of theta is opposite over hypotenuse. Cosecant is the reciprocal of it. I also mentioned that cosine of theta is adjacent over hypotenuse. Secant of theta is the reciprocal of it. And then tangent of theta is opposite over adjacent, and cotangent is adjacent over opposite. So that's basically what I work on. Now, let's take a look at number 17 and 18. I need to create, with the point that is given, I need to create an angle of 90 degrees at the x-axis. The x value, I'm given an x and a y value. The x value is the one along the x-axis, so I'm just going to say this is negative radical 17. And then this right here, the y value is negative 8. I'm just looking at a triangle. Let me make my triangle a little bit bigger. Here's theta, because remember theta is at the corner, right where the origin is. And I have that this is negative radical 17. I have this is negative 8. Now for cosecant, I need hypotenuse over opposite. I don't seem to have a hypotenuse, so let me solve for my hypotenuse. Let me call it x at this time. So I have that negative 8 squared plus the negative radical 17th squared is equal to x squared. Negative 8 times negative 8 is positive 64. Now in this other case, negative times negative is positive. Square root of 17 times square root of 17 is just 17. Now 64 plus 17, that's 81. So x is the square root of 81, which is better known as 9. So now what I need is hypotenuse over opposite. I'm just going to call this 9 over negative 8. Simplify your fraction if possible. Bring the negative sign to the front. Negative 9 over 8. How do you type this? I'm going to write it here at the bottom. Negative 9 over 8. Now let's take a look at question number 18. Once again, let me make a 90 degrees on the x-axis. My corner at the origin, that's where my theta is. So when I look at my triangle, this is what I'm looking at. My x value is along the x-axis. So you guys can see it's there. My y value is the one vertical, the one that goes up and down. So it's a negative 2. Now for tangent, I need opposite over adjacent. I have what I need. I don't need to solve for hypotenuse in this case. I have what I need. I have the opposite is negative 2. I have the adjacent is negative radical 5. So let me write this as negative 2 over negative radical 5. I cannot have radicals at the bottom, so let me multiply top and bottom by radical 5. I cannot have radicals at the bottom. I know negative with negative cancel out, so on the top I have 2 radical 5. At the bottom, radical 5 times radical 5 is 5. I look at my fraction of my whole numbers, 2 over 5. If you can simplify it, by all means simplify it. In this case, we cannot. The way I will type this will be 2 radical 5 over 5. All right, now let's take a look at number 19. One thing I must remember, the angles. When the angle is traveling counterclockwise, it's a positive angle. When the angle is traveling clockwise, my angle is going to be negative. So now here we see the signs. Number 19 is positive because it's going counterclockwise. Number 20 is negative because it's going clockwise. Now for the reference angle, we just want to know what's the angle closest to the x-axis. So I'm looking at how big is this angle. Let me call it x for right now. Let me zoom into my picture. Now let's take a look at this in black. I know this right here is 90 degrees. This right here, it's another 90 degrees. This right here it is 90 degrees. This right here it is 90 degrees. This is 90. This is 90. And this is 90. I see I have, let's see, 1, 2, 3, 4, 5, 6, 7 90s. So far, remember, I'm just going to go 90 times 7 is 630. So in black, I have 630 degrees because I'd have 7 90s. All right, 90 times 7 is 630. Now, notice how my angle originally, the whole red angle is 700. And I said in black, I went 630. So I'm going to say that this angle is 70. Since I have already gone 630 out of the 700, for me to know how much is left, I just went 700 minus 630. So I know that's 70. I know that 70 plus x is 90. I'm just going to say my angle that I'm looking for is 20 degrees. Remember, when I travel from one axis to the other axis, from an x-axis to the y-axis, the space in between the axes is always 90 degrees. So that actually what helps me find what I have left. Now let's take a look at here. I'm looking for, right, from here, the closest to the x-axis is this way. So this is the angle that I'm looking for, x. Now let's see what I have. Let's see in black. I start here. The negative is just for me to know I'm going clockwise. But so far, that's 90. That's 90. That's another 90. That's another 90. And that's another 90. I have 5 90s. So I have 90 times 5 is 450. In this case, I'm thinking of negative just because I'm going clockwise. So in red, I was told that the whole thing is 460. So far, I've gone 450. So I am going to say that this measurement in red is 10 degrees. I've gone 450 out of the 460. So that is 10. And I know that x plus 10, what I mean x, I'm talking about this x, and then this 10. X plus 10 is 90. Subtract 10 from each side. X is 80. So the angle that I'm looking for, my reference angle in this case, it's 80. Once again, I want to know what's the angle closest to the x-axis. Once we talked about reference angle, even though our angle was given either positive or negative, we see positive in number 19, negative number 20. Reference angle, when we write it, it's always positive. Now, when we do write the measurement of the angle, I'm looking at numbers 21 and 22. Here, we do use signs. Positive if I go counterclockwise. Negative if I go clockwise. So let's see. I'm going clockwise to number 21, so far I know it's going to be negative. I see that my angle, I want to see how much I have. I'm going to say that's 90. That's another 90. That's 90. That's 90. That's another 90. That's another 90. That's another 90. That's another 90. So far, let's see how many 90s I have. I have 1, 2, 3, 4, 5, 6, 7, 8. 90 times 8 is 720. So far in black, I have 720 degrees. I am missing some in red. I want to know how much is that angle, because that I'm going to add to my 720. Now, I know that angle in red with the 75 in green, That makes 90 degrees. So I'm thinking 90 minus 75 tells me that that angle in red is 15. So I know that measurement is 15. And I said I was going to add it to my 720. So now I have 735 because my angle is going clockwise, negative. So the measurement of my angle is negative 735. Now let's take a look at number 22. I'm going to start here. And I know that that's 90. That's another 90. That's another 90 degrees. That's another 90 degrees. And that's another 90 degrees. So I have 5 90s. I'm just thinking 90 times 5 is 450. So in black, I have 450. I still need to figure out how much is that angle in red. I know the angle in red plus the green angle combined is 90. So I'm thinking, well, 90 minus 50 is 40. So then that means that that angle in red is 40, right? Because 50 and 40 combined is 90. So I know that's 40. So in black, I have 450. Let me add the 40 from the red. That gives me 490 degrees. My angle is going clockwise. That means it's negative 490. If it was going counterclockwise, it would have been positive. All right, the last part from this review, we're going to convert each degree measured into radians and each radian measured into degrees. Okay, so let's take a look. I mentioned when we covered this section, I said that 360 degrees is equal to 2 pi when it comes to radians. So what I'm going to do, I'm going to multiply this. I'm going to use a fraction. I'm going to use 360 and 2 pi. If my information is given to me in degrees, not this case, but if it was given in degrees, I write 360 at the bottom and then 2 pi on the top. Whatever I have, the information the way I have it, if I have degrees on my fraction, put degrees at the bottom. If my information is given to me in radians, I see a pi, then put 2 pi at the bottom. So once again, my information is given to me in radians, so I'm going to write 2 pi at the bottom and 360 degrees. If the information was given to me in degrees, put the 360 at the bottom. All right, so let's see. I can simplify things a little. The pi with the pi cancel out. 6 with 360. All right, let me divide each by 6. So that gives me a 1 over here. And that gives me 60 over here. Let me clean things a little. I have 19 over 1. I'm not quite done yet. Times 60 over 2. And you guys might be like, well, I can still simplify. 60 over 2 is 30 over 1. Now I'm just going to multiply 19 times 30. 19 times 30 gave me 570. 1 times 1 at the bottom gave me 1. Now 570 over 1 is just 570. Now let's take a look at number 24. I'm going to write this as 360 over 2 pi. I'm going to simplify. 360 with the 6 becomes 1 and 60 because I divided each by 6. The pi with the pi cancel out. So right now, I have a negative 5 over 1 times 60 over 2. All right, 60 over 2, that becomes 30 over 1. So when I multiplied on the top, when I multiply straight, I have 150 over 1. Forget the negative sign. Now 150 over 1 doesn't just that simplify to negative 150. Okay, so this is just the first part of the test.